Hello, everyone, and welcome to the explanation for the Trig star worksheets that we have for week 9. This is for MAT122 or college Trig. The Trig star is, I think I explained this in class a while back, and you may have heard this, maybe not. But basically, the Trig star is a test that the surveying is a job basically where you go out and you use real-world geometry and trig a bunch to figure out how land to describe land to engineers basically. If you ever see those guys with the high visibility vests kind of standing in the middle of the road or in a field, and they're kind of looking through a thing on a tripod, looks like a camera. Those are surveyors, and that's who puts on this kind of high school test every year. We are not going to be taking it through them this year because it's all kind of canceled due to COVID. But we are going to be taking it, just an old version of it, just to squeeze it in because, we have the time and it's real world trig applied. So I think it's going to be worth our while to do this. So with the Trig star, it's a standardized test. Typically, in the past, the kids have gotten an hour, and it's very, very strictly an hour. If you use you can't go over an hour. They stop you at the end. But if at the end of the hour you have the best scores, so the most accurate answers, and you did it the fastest, then you would win. And every year they gave out, I think they gave out $300 in cash to some kid at our school who did the best. And then if you did the best in our district in Cherry Creek schools, I think they gave you $3,000. And it wasn't like a scholarship or anything like that. It was actually $3,000 in cash. So it was a really cool prize. I think they gave you a plaque too, but unfortunately we won't be doing it the proper way this year. We'll kind of be just doing a mini version of it here. And I'll come up with some type of reward for the person who does the best, but it's not going to be $3,000. So, yeah. Okay, so the way the test works is there's only 4 questions. The first question is always structured the same. Second question is always structured the same. Third question is always the same. And then the fourth one gets exotic. Sometimes they're really, really easy. And then sometimes, some years, they're really, really complex and no one gets it completely right. So I'm going to be talking about the 4 different questions, the 3 different questions at the beginning, and then I'll give you an example of a 4th one. But they're all kind of done in similar ways, okay? So for the first question on the Trig star, it starts off with just a right triangle. They always give you the same 2 sides. So they always give you one of the legs, and then they always give you the hypotenuse. And all you have to do is find one of the angles and then the other leg. Okay, so here, looking at my answer key, I have 4 problems. One of them's from the 2018-19, one's from 2017, one's from 2013, one's from 2014. So these are all real questions from old tests. So the one that I did was the 2018 problem. The first thing that you'll notice is that they give you the distance and of one leg and then and of the hypotenuse. Okay, so what we need to do first is find the other leg, and we're going to do this real simply by just using the Pythagorean theorem. Okay, so I showed my work here, a squared plus b squared equals c squared. Plug everything in, square root it, and you get the answer 724.85. Now, you got to be really careful. If you notice on the problem, it says round your answer to the nearest hundredth. And they are very, very picky on the exam. If you put like 0.84 on this one instead of 0.85, they would count it wrong. So the rounding has to be exactly right, okay? So be very, very mindful of that when you're doing these problems. Okay, so now it asks us to find the angle ACB, and I have that here in red. Well, it's a right triangle, so we can use SOHCAHTOA. So the adjacent side to that is what we have, the 752, and the hypotenuse is what they gave us as well. So we have adjacent, hypotenuse, so I decided to use cosine. The cosine of our mystery angle is going to be the 752 over the 1044. I inverse cosine both sides to find my angle, and I get it in decimal form, and I have to switch that into degrees, minutes, seconds, because that's what they asked for. So on the calculator, you just go into the angle menu, and one of the first choices is change my answer into degrees, minutes, seconds. You say yes, please. And that spits out 43 degrees, 56 minutes, 41 seconds. So that is how I do number one. Number one is always the same. They just give you slightly different numbers. If you look at the 4 problems that I gave you as an example, you can see they're virtually the same problem every single time, okay? So that is number one, okay? Number 2, slightly longer problem. They're asking for more, and it doesn't really start off with a right triangle. In fact, it's not a right triangle, but they do draw this altitude in here forming a right triangle, and you can use some stuff from that. So once again, I did the 2018 problem. I have it all right here, and I have it all labeled. Blue stuff is what they gave us, and then the red question marks are what we're looking for. You will have to use the store button on this, and the reason you have to use that is because if you round too much at the very end, your last answer will not be accurate, because the rounding kind of carries throughout the whole problem. So I used a lot of storing on this, okay? And basically all you do is on the bottom left, there's an STO on a TI calculator with a little arrow. You hit that, and then you give it any letter you want. You can give it A through Z, any letter you want, and then it'll store that number in the form that you have it in the calculator. So meaning the decimal, the entire decimal will be stored in the calculator, and you can recall it later when you're doing stuff. So it's really, really helpful. We'll talk a lot more about that in class because it's kind of hard to do a video about it, but that's what we're gonna have to do, okay? So, for this triangle, the first thing I did was I found the angle EGF. So that's one of the angles that they're asking for right at the beginning. Well, they gave me 2 of the angles, so to find the third one, I just subtracted all from 180. And if you do that, you end up getting a decimal. It's about 22 point blah, 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 blah. Well, you have to switch that into degrees, minutes, seconds, and that's what I did. And I stored that as angle, or as letter C inside my calculator, okay? So then, once we have that angle, what we're gonna find is EH. Well, EH is pretty easy to find, the length of that line, because they gave me the angle at E, they gave me the hypotenuse. So all we're gonna do is use cosine because I'm looking for the adjacent there. So the cosine of 44.49 equals the EH I'm looking for over the 298 or 297.98. So if you do the work on that correctly, multiply both sides by 297, you should end up with the side length of 212.57. So that's how I get EH. So now I want to find FH, so the length of that altitude. Well, we just used, we just found the EH in that right triangle. So to find this one, we're just going to use sine. And I could use Pythagorean theorem, but then you're kind of relying on your last answer being correct. If you goofed on it or didn't round correctly, there's no way this answer will be right. So my recommendation is that you always use the stuff that you're given as much as possible because you know it's right, okay? So for this one, I'm using opposite over hypotenuse. So sine of the 44.49 equals our FH over the 297. Simplify this, I get 208.82, and I stored this as letter D on my calculator, okay? So now, when you start trying to find f of g, FG rather, the length from F to G, we just found D, and we're going to have to use that to help us do this one. We also know angle C, we found that earlier, but now since I stored them, I can recall them and use them throughout this problem. So when I did it, I just did sine of C, and that's a real number because C is stored in our calculator. is equal to D over FG. Well, D is a real number. We just found that when we stored it. And then FG is what we're looking for. So when I plug into the calculator, I just do sine of alpha C, and then that'll give me an answer. And then I divide D by that, and you end up with 542.08. Now, I don't have to store that because I'm not going to use it later, but you can if you wanted to. Okay, the last one I got to find is GH, so that bottom line. The way I do that is I do the tangent of C because it's opposite over adjacent. Opposite is that line D that we found earlier. And if I just plug this in correctly using my alpha C and alpha D, you end up with 500.25. And that's how you solve that question. So that is question 2. Question 2 is always done the same way. It'll involve right triangles and solving some of them over on the left and then solving some of them over on the right. But basically, you're using one to find the next, to find the next, to find the next. And you got to store some of those letters as you go just to keep everything accurate. Okay. Now, question C on the Trig star is a really tricky one. It's tricky because you get a right triangle on the top left and you have a right triangle on the top or on the bottom right, but the two other angles we don't know, so we can't really use any of the right triangle stuff immediately. It doesn't really help us, which is unfortunate because right triangles we know kind of a lot about. So let's look at the question from 2018, and I'm going to show you how to do this one completely. So the first thing you're going to do on question 3, no matter what, is you're going to draw the line from angle B to angle D. So you're going to draw the other diagonal. Now the reason we're doing that is because we need to, we kind of have a lot of information on each of those triangles that aren't right triangles, if that makes sense. Okay, so the first thing that we're going to find here is we know on the overall quadrilateral, on the overall four-sided shape, we have 1, 2, 3 angles, and we can find the fourth one really, really easy. The way we do that is we have two 90-degree angles, so I'm going to subtract those from 360, and then I have this angle A that they gave me it's in degrees, minutes, seconds, so you got to convert that into just regular degrees. So I typed that in as in degrees, minutes, seconds. I switched it to decimal and I stored it as A. So then I subtracted that from 360, and what you end up getting at the end of the day is 101.44. Now that is not one of the one of the things they're asking for in the problem, so we don't have to do any switching that to degrees, minutes, seconds, or anything like that. So we just leave it like that. And so I stored mine as angle D. Okay. From there, we got to find the length of BD. Now, BD is the line that we drew. Mine is in blue. And the way we're going to do this is we have the angle D. We have the two side lengths that they gave us. So we're going to use the law of cosines. Now, I stored the 692 that they gave us at the beginning as B. I stored the 387 that they gave us at the beginning as C. So now I'm going to use all these letters that are actual numbers in my calculator and just plug it in one step. So if you do all that, you end up with some big number, you square root it, and you get BD, which is 857.81. I stored that as angle E, and I didn't round it. I stored the actual decimal in my calculator, okay? So I have that now. So now we got to start finding stuff that they want. Oh, not yet. Okay, so now we're going to find the angle BDC. And if you look at my picture, it's angle F. Now, the way we do this is we're going to use law of sines now because we have BD and we know the angle across from it, which was D. And now the side B, or 692, is across from F, and we're going to use that to help us find that angle. So if you find that, you just plug it in this situation right here. We find out that angle BDC, which is angle F right in our picture, is 52.3 degrees. Well, that overall angle is a 90-degree angle, so we subtract that 52.3 from 90, and we end up with 37.7. So that's the other part of that angle. So I called that angle G. So now, what are we going to find? we're going to find angle BA. And I think BA is one of the ones they're looking for at the very beginning of this problem. Well, the way I'm going to find this is I have angle A, which is across from BD, and that's going to be part of our law of sines. And now we have this angle G, which is across from the side we're looking for, BA. And so I set it up like this. I have E, A, and G all stored in my calculator, so I just use those as we go. And if you do this correctly, you should end up with the side length for BA is 535.21. Now, that is one of the answers that they asked for, so I write it on the line. I round it correctly. I don't round it when I store it. I keep the unrounded version in my calculator, and I called it H. So that is in my calculator. So now, I'm going to find the missing angle for ABD. And the way I do that is I know two of the angles, so I'm going to find the third by using 180 minus the two others. And you end up with ABD being 63.74. Well, I called that I because now I'm going to use law of sines with it. So for I, what we're going to do is we're going to stick the angles and the sides across from them into law of sines. Okay, so if I do that correctly, I get this situation right here, and I'm solving for AD. So I have E, A, and I all stored in my calculator. I do this correctly, and I end up with J, or AD, which I called J. And we end up with 784.91. That's one of the answers that they're looking for. So I put that on my paper, and I'm good to go. All right, so now, last thing we need to do is we need to find CA, which is the line that goes from A to C, goes across. It's a diagonal. So we have a lot of things to use here. The way we're going to do this is we know J, we know C. That's a right triangle, so we're just going to use Pythagorean theorem. If we do that correctly, we're going to get J squared plus C squared equals our mystery side length, CA squared. So if you do that correctly, you end up with 875.21. So the third question on the Trig star is very tricky in that they give you a lot of right triangles, and I have to deal with them. Well, you can't really use any of the right triangle properties until the very, very end. So it's kind of a pain in the butt, but that's always what triangle or the third problem on the Trig star will look like. Okay, so that is it for the video. I'm going to go over one of the questions on the fourth problem for Trig star when I see you in class, because it's so complicated I don't want to even try and put it on a video. But if you want to look at the Trig star fourth problems, they're all in there. I put all the answers in there as well. Like I said, sometimes they're easy, sometimes they're pretty tough. I'll let you look at those, and then, like I said, we'll do one in class. Okay, so that is it for this video. Have a lovely day, and I will see you later this week. And email me should you have any questions. Thanks a lot. Bye.